Welcome to our session, VSP2774, Supercharge your VMware deployment with VAAI and VAAI-enabled storage. How many of you guys have heard about VAAI? All right. So what are you doing here? Is any happy hours already? Good. I'm glad you've heard about VAAI. How many of you guys have actually used it and seen it live in action? Okay. Now I wish I had a demo instead of slides. Then we could have some fun. We'll have fun regardless. My name is Abubakar Diari. I work for Hewlett-Packard. I'm a master technologist. I use Hewlett-Packard focusing on VMware and a few other things that I won't bore you with. But primarily, one of my primary functions is VMware and enabling our storage with all of the VMware features. So working closely with VMware, ensuring that when they have new technology coming up that are storage related, that we are also right there on point with them, okay? To my left here is Lucas. Lucas, you want to introduce yourself?
Yeah. Hi. Can you hear me back there? Lucas Nguyen with VMware. I'm a corporate staff technologist. Basically focus on all the vStorage API integration for the global partners, including HP.
All right. So today we're going to talk about VAAI. This is a quick overview, right? High-level agenda, right? But my real goals here for the presentation today is when you guys get out of this room, I want you guys to be able to understand, one, what VAAI really is, right? How to use it, how you configure it, right? And then the inner workings, right? Like the stuff that you probably normally wouldn't touch, right? How do you enable it? How do you ensure that VAAI is working? How do you troubleshoot this thing to make sure that it's actually doing what it's supposed to? Those are the things I want you guys to learn. And then I got one slide or two on some considerations and things that people traditionally don't think about when they think about VAAI. Okay, and we'll explore a little bit of that, right? And then we'll close, right? And send you your way, and you'll be VAAI experts. And hopefully you can tell everybody what you've learned here today and how great it was, okay? So without further ado, I'm going to turn this over to Lucas, and Lucas is going to get us started, and then I'll pick it back up and close this off. Go ahead, Lucas.
Great. Thank you, Abubakar. All right. So before we start VAAI, perhaps it's going to be a review for many of you since you are already using it. In the last decade, I would say 7 years ago, the focus at VMware was to provide consolidation, right? Hardware consolidation. So we solved that problem for the industry, reducing server consolidation, saving your power, CPU resources, etc. The next phase was to convince the industry to move the application into the virtualization arena. And I think we've been successful in doing that. In fact, the keynote speaker yesterday from my CEO, you probably seen the data that over 50% of the workload now are virtualized, right? That's a tremendous note for VMware. So in the last 2 years, where we are going, where VMware have been going, actually started in development at least several years, is providing more agility to your IT infrastructure. So IT agility is the buzzwords that we're marching order to. And so with beginning with a lot of our vStorage API we roll out, the core problem to solve is in the area of performance and scalability. And VAAI, or vStorage API for array integration, part of the larger vStorage umbrella, solves this problem by convincing those storage partners to make a lot of primitive changes in the SCSI layer to provide better VM cloning, a more efficient way to deploy template, faster migration, right, and all this scalability, which I'll touch with the new locking mechanism. VAAI basically provide these two key characteristics. If you listen to yesterday's keynote from Paul, the list that he listed for the changes in vSphere 5, all of those are all changes to storage. And storage is so important to VMware, to virtualization, because over 90% of the virtualization structure, these millions of VMs, over 90% of them lives on storage. So what we change in storage enable us for cloud computing. Okay. So because the arrays doesn't speak VMFS, a lot of the operation we have to offload to the storage array. And this is the trend that we have been observing for many years, starting where VMware focused on the virtual machine layer, a lot of operations are offloaded to the physical layer, starting with Intel chip, the AMD chip, for example. So it's natural for a lot of the operation in the SCSI layer, the data path, to be offloaded to the storage array. So what is VAAI? So as I mentioned earlier, VAAI is part of a set of vStorage API umbrella that HP worked with VMware to provide all of these functionalities also. HP is a key partner for these vStorage API umbrella. The first is vStorage API for Site Recovery Manager. So Site Recovery Manager, in simplicity, think of it as a vCenter plugin. You can manage your planned disaster recovery from this vCenter plugin. It's a single pane of glass. Essentially, Site Recovery Manager provides a cost-efficient way for you to replicate applications to a failover site, right? Starting with SRM5, we support now the first in the industry hypervisor-based replication, providing replication for your applications to multiple sites, right? Also in SRM5, we provide bidirectional support, automation of failback. And HP is a partner at VMware providing the agent, the storage replication agent that SRM calls to migrate from site A to site B. The next one is API for pluggable storage architecture, which HP fully support. The PSA is our native multipathing. There are components within PSA you're familiar with the multi-path, which we provide when you load ESX is natively loaded. PSP stands for Path Selection Plugin. It's something that VMware develops. And SATP is basically the actual storage array type plugin that ESX would know which one to load when it connects to which HP storage. And HP does full support for all of these. And by the way, back to the PSP, HP supports the fixed policy, the MRU policy, and the round-robin policy. Let me skip over to VASA. VASA is one of the most important changes that we roll out for SRM for vSphere 5, and HP is also an active participant working on this API. So this is the engine behind profile-driven storage. And what profile-driven storage is basically, as a participant to VASA, HP is a vendor provider. It talks to, because they gather the attributes from their storage array, it is consumed by our vCenter through the software management agent. And through there, we have a better understanding of the array characteristics. So from VASA, profile-driven storage is able to carve out gold storage, bronze storage, silver storage. So when you create a virtual machine, you can associate the virtual machine to this profile-driven storage, guarantee of service, right? So that's what VASA does. And of course, the vStorage API for data protection, HP Data Protector 6.1 has integration. It's basically an evolution of our VMware consolidated backup. So back to VAAI, what it is basically another set of API, part of this vStorage umbrella, and it is providing advanced SCSI operation, offloading the operation normally done at the ESX kernel level to the storage array, providing better, efficient way of data operations. Okay, so here's a quick snapshot of VAAI that we roll out support since vSphere 4.1. That was phase 1. Phase 2 support, we added more support in the area of thin provisioning. In 4.1, which we'll touch later, very key importance are full copy, the atomic test and set for replacing SCSI 2 reservation, and the write same, which is the SCSI 2 standard. Also, the phase 2, beginning with vSphere 5, we support up to par support in the block space. We extend that support to NAS storage. Okay, so it's a quick snapshot of the changes. So let's take a deeper dive into each of the primitives for VAAI. So beginning with 4.1, we supported these 3 key primitives. The first one is one of the most important ones to address the scalability problem. The common question is how many virtual machines can you put on a single LUN, on a single data store? There are concurrent SCSI operations or backup operation, for example, that compete with the same LUN, causing a lot of SCSI reservation conflicts. So to solve that problem, atomic test and set is a replacement, it's a new algorithm to replace SCSI2 reservation. So atomic test and set, or ATS, protects the metadata or VMFS file system, allowing you to scale to a large ESX farm sharing a single data store. And it is done by ATS changing a sector on disk instead of locking the LUN with SCSI2 reservation, because with SCSI2 reservation, normally it requires locking out the concurrent host access. So now locking is done at the block level and not at the LUN level. So because of this, also the other significant change ATS brings is that it significantly reduces the amount of SCSI commands required to acquire an on-disk lock. So it significantly saves a lot of SCSI conflict reservations. So the use case for atomic test and set is normally any cluster-wide operations like vMotion, storage vMotion, any locking operations, power state operations, like you power on the virtual machines, suspend, resume virtual machines. The next primitive full copy, which I have more slides to go into the SCSI command, but basically is an extended SCSI command. It's now, actually, since last year, part of the T10 SCSI standard. And basically, full copy is leverage the array to mass copy, snapshot a large amount of block, for example. So a typical clone size is from 1 megabyte to 256 megabyte. So a typical transfer size is 1 to 8 megabyte. By default, with full copy, ESX will use a default of 4 megabyte. So the example use case here for full copy is when you import a VMDK from template, when you snapshot VMDK of virtual machines or storage vMotion operations. The third primitive, block zeroing or write same is the actual SCSI command, is basically zeroing a large amount of blocks. With this write same command, it reduces the time to provision a virtual machine now, because the operation is uploaded to the array, and you don't have to have multiple writes commands from ESX to the array, much more efficient. And the example use case is, for example, if you create a fault tolerance virtual machine, you require to use an eager zero thick disk. So when you clone a VM, clone a eager zero thick disk with write same command, it significantly saves the amount of time that you create the VM. Okay, so this is phase 2 of VAAI. Phase 2 is supported as of vSphere 5. We added support similar in the full clone for block. We now extend support for NAS. The other one is space reservation, basically unmap command in the area. Space reservation here is creation of thick virtual disk. And the other one is the extended statistics to report overcommitted statistics for NAS. The other command I was thinking of is the unlink command. Okay. All right. So for thin provisioning, this is part also of phase 2 support for VAAI. This is supported as of vSphere 5. So in the area of report capable, there is, when you do a SCSI inquiry, you get a read capacity command back from SCSI command. There's a bit called TPE, thin provision enabled bit, in the read capacity. So from that, ESX will know that the LUN is thin provision or not. The other component of thin provisioning is out of space condition. In the out of space, traditionally before this phase 2 support, when you run out of space, your virtual machine would just crash, right? So now we have a mechanism. Basically, we do a check condition. There's a sense key from the array, I am not ready. There's an additional sense code qualifier from SCSI that say I'm not ready, and it's space allocation in progress. So when ESX kernel sees that, we delay and retry the command when we see this. There's another condition when we get a check condition, there's a data protect, and the additional sense code qualifier come back with space allocation fail write protect. So when ESX detects that, then we would not retry, we would just pause the VM. Right? So instead of crashing the VM in the past, you have a graceful condition. Also, there's a threshold notification. There's a Vans warning now from the SCSI mode sense, and from the GUI, we can report these thresholds. And the other component of thin provisioning here is a dead space reclamation. Basically, the example here is when you storage vMotion to another location, there's dead space, and we need to claim that dead space, and we use the unmap command. I think there's a GUI slide to demonstrate this. Okay. So here's a pictorial representation of what I spoke about for atomic test and set. So on the left here is a very simple example showing two ESX servers sharing the same LUN. Without VAI, because you use SCSI2 reservation, it will require you to lock this LUN from concurrent LUN access. So with VAI, because atomic test and set makes changes, the sector on disk at the block level, we do not require ESX to be locked out, and you have concurrent LUN access. So with ATS, this allows you to scale more, do more operations. Here's a pictorial example of an Xcopy primitive, a full copy. So without VAI, normally when you issue a, okay, I went too far here. Normally when you issue a copy, a clone of a virtual machine, for example, ESX would have to issue multiple SCSI commands to acquire a lock, and then read data from the storage array into ESX, and then write out to the specific block being requested. So a lot of SCSI command required. With VAI, ESX will only have to issue a single extended SCSI command, a T10 standard command, and allowing the array to do the offload. I apologize, I keep pushing the wrong button here. Okay. So here's a same example. Basically, you can do a clone within the storage array or with multiple across different storage array. A similar example. In this case, with VAI, the full copy would just do the cloning at the array level, saving ESX memory and CPU resources. And in the future slide, Abubakar will have excellent performance data to demonstrate how fast we have made improvement in this area. So here's a pictorial example of write same primitive. Without VAI, ESX would have to issue multiple write commands, write same, repeating the write same command until you complete all the zeroing of the blocks. Without VAI, with VAI, you don't have to issue multiple write command anymore, or single write same command to all these blocks. The storage array would do all the block zeroing. So much more efficient with VAI. Okay, so for the thin provisioning, here's a pictorial example, is without VAI, when you delete the virtual machine, it is deleted from the VMS data store, but in reality, the space being reserved is still here, right, shown here. So with VAI, what you want to see is this space here be reclaimed. So with thin provisioning, so as the click shows, when you delete a virtual machine, your virtual machine is gone. From the VMS layer, it's gone. And now with the unmap command, you can reclaim that space to provide more storage capacity. Okay, with space reservation, it's just a simple slide showing that you can now, with VAI primitive on the NAS space, request for a thick disk, right? And that was not possible before, because with 4.1 and previous releases, when you create a file or a mount point, it's thin provision by default. So with VAAI, you can now have a thick provision. Basically, storage is pre-allocated for your use. And here's a similar pictorial for NFS full clone. With VAAI, of course, you don't have extra SCSI commands at this layer, so you save a lot of bandwidth, but all the operations are done locally at the array. Here's an excellent slide that Bubakar put together on giving you a summary of the primitive name that I discussed, the equivalent name, and within vCenter, you'll notice these options when you go to command line. For example, atomic test and set under VMFS3, it's noted as hardware accelerated locking, and the specific opcode vary by vendor. For example, here shows X89. The cloning block in ESX Virtual Center, you'll notice that it is listed under data mover, hardware accelerated move. By default, it will be 1. It's set to 1. And it is the extended copy that I mentioned earlier. And for zeroing file, it is shown in vCenter as data mover, hardware accelerated, and NIT. And as I mentioned earlier, is the correct SCSI command is write same command. And the out of space condition, and I think I touched this already, depending on the type of sense key and additional sense code qualifier come back to ESX kernel, either if it is a not unit data protect or space allocation in progress, then we pause the VM, or in the case of space allocation fail, then we will stunt the VM. Okay. Again, there's the unmap command for SCSI command, as I mentioned. And for vCenter name, it is under enable block delete. So this is a good summary slide showing you the support of what is for block and what is for NAS. And these slides are available to you for download, so you can refer back to them. And similarly, all of these commands that I touch on are now supported as of phase 2 for VAAI. Okay, so with that, let me turn to Abubakar to do the configuration.
All right, thank you, Lucas. All right, let's talk a little bit about configuring this stuff and you know how you go about figuring out if this is actually working for you the way it's supposed to. Okay, so the good news is in vCenter today, right, and vSphere in general, there's nothing you have to do, right? All these primitives are enabled by default. So you would only have to take an action if you wanted to disable this stuff. But who would want to do that? You know, you may have your reasons for testing or whatever. But for production, just leave them there, right? If you're not using VAAI, you don't have a plugin, they don't interfere with any of your production, okay? So just leave them turned on. So then when you install your plugin, you're ready to go, okay? You don't have to worry about which ESX servers did I turn them on or turn them off on, right? What I'm showing you here on this slide is what Lucas was showing on a previous couple slides ago. It was a summary of what do the primitives map to when it comes to vCenter. Okay, so it's always good to know, fine, I understand what this is doing, but how does it do it, right? So that's kind of like what I want to talk about a little bit. So there's these variables that you can get to on the command line on ESX. Okay, so if you log into your ESXi5 or if you log into vCenter, ESXi 4.1 or ESX 4.1, you can get access to these variables, right? These primitives, and you can toggle them on and off using the ESX CFG command. Okay. This block delete one, only available through the command line. There's no vCenter value for it. This is the unmap primitive right here. Okay, this is how you would turn on and off unmapping, the ability to reclaim space in a thin provisioning pool. Okay. In vCenter, the view is slightly different, of course, but it's the same thing. Okay, if you go under vCenter advanced settings and you look at data movers, you'll find these two variables in there. Okay, hardware accelerated init and hardware accelerated move. Okay, those two variables will respectively take care of write same, right, zeroing, basically initializing a VMDK, claiming all the space up front, or cloning, right, with the move. Okay. The hardware accelerated locking is also visible through vCenter. okay, you'll find it in a slightly different spot. Okay, you got to go to VMFS3 down here, under advanced settings, and you'll find that is also turned on to 1, okay, by default. Okay, and again, the delete, hardware accelerated delete, it's not available on vCenter. Okay, now this slide here is a really, really important one. So this is one that you want to write down the information. I always get the question, when do I need a plugin? Okay, this is when you need to plug it. Then I explain it, and then 2 weeks later, I get the same question from the same person. When do I need to plug it? Okay, so let's try to go through the decision tree here. It's very simple, actually. Now that we have ESX5 and ESX 4.1, that's when everything got complicated. With ESX 4.1, you always needed a plugin, regardless of, who, what array, what vendor, the plugin is built in or the plugin is delivered through a website, you need a plugin. Because some people come and tell me, well, I have an array that I'm using, but I don't need a plugin. I'm like, why? Because you didn't download it and install it that you don't need a plugin, or because you don't know that there's one built in? Ah, okay. Well, there's some arrays that are actually built into, had their plugins built into ESX with 4.1, okay? For example, HP left hand, the P4000, plugins built in. You don't have to go to any website, download anything, okay? You load ESX 4.1, you're ready to rock, okay? If you go, for example, to the P2000, our MSA array, if you load ESX 4.1, you might sit there a long time. You won't see any VAI thing happening until you load a plugin, right? So then you got to go to a website, download the plugin, install it, and then you're ready to go, okay? If you're running ESX i5, though, okay, you may or may not need a plugin. And that's when this first column comes in. And the first question you ask yourself is the firmware that I'm running on the storage system T10 compliant for VAAI operations? And if your answer to that is yes, right, then you do not need a plugin. Okay? Then you can take ESX i5, that array vendor, and their VAAI T10 compliant plugin, and the two will talk like best friends. Okay? However, because not every vendor's array is VAAI-enabled yet, for T10 specific VAAI-enabled, you may need a plugin for some of those arrays. Does that make sense? Right? Do we understand when we need a plugin and when we don't? Okay, good. And so what's the plugin really? So the plugins are delivered in this zip format. We like to call them bundles. Some people call them VIBs. And you pretty much just download this from the vendor website and you install it. Okay? How do you verify that VAI is actually doing what it's supposed to? Okay? So what we talked about so far is all the primitives, the ones that actually do operations. There's a couple components of VAI that is important that you understand and what they are and what they do. Okay? One of those is a filter driver, and the second one is a plugin itself that a LUN that's discovered on your storage systems attached to, okay, in order to enable VAI operations, right? How does that work? So on the right here, I'm showing a high-level view, and I'm saying high-level view of the very complicated ESX architecture, okay? And the pieces that I'm talking about, and the point on this slide here, is these two components here, the actual plugin and the filter driver, okay, the VAI filter. So how many of you guys have played with PSA, the pluggable storage architecture in ESX? That's the thing that handles all the multipathing and stuff like that. No, not many people? A few? Okay, cool. So when you present a device to ESX, he has to identify it, right? So that then he attaches it to some module inside of ESX that understands how do I do multipathing to this device, right? Do I do round robin by default? Do I do MRU by default? Is this an active array, etc.? With VAI, it's the same thing, right? When you attach a device to ESX, ESX needs to understand which plugin is going to handle VAI operations, right, for this device. Okay? So what happens is this filter driver is the one that's going to identify this device from PSA, from the layer underneath of it, and say, oh, okay, I know who this is, and I know what plugin I need to attach that device to. And once these two operations occur, now you have a filter driver that claimed your device. In this example, I'm showing the P2000 and, let's see, it's probably in, this is our high-end array, the P9500 XP. And down here, I'm showing the actual plugins that I attach to those devices. Okay? So those two things are very important. So if you, for example, working with ESX 4.1, okay, and for some reason you're not seeing VAI operations, you're not seeing what you expect, right? Go to your ESX server through the command line, run this command, okay, and make sure that the plugin is loaded. If the plugin is not loaded, if you need a plugin and the plugin is not loaded, you shouldn't see an entry like this one in the plugin in the table, in the list that shows up. And that's probably your first clue that, okay, you know what, I'm not going to get any VAI here until I get that plugin in there, okay? Now, even with ESXi5, when you don't need to install a plugin, these claim rules will still be valid, okay? All right? We're good. The green box. Only reason I put that in here is to kind of start showing you the paradigm shift with the namespace in ESXi5. I always love how, every major version, VMware decides to change the command line. Okay, you know what? This year we feel like doing things backwards. So instead of doing core storage, we'll do storage core. Okay, great. Now I got to learn that. Okay, but anyways, the namespace is different in ESX CLI now, right? So for those of you, just like me, that like to scrape a whole bunch of stuff and you'll grab coffee and wait for it to happen, and then I had like a good hour of work my whole day, you want to know about this kind of stuff. All right. The next step is, once you've loaded your plugin, right, you know the claim rules are loaded and you know that your device has been claimed, the next thing you want to do is you want to make sure that the device that you've presented to this ESX server actually shows up in vCenter and also through the CLI and saying that VAI is supported, okay? So in vCenter, there is a hardware acceleration tab that was added as of vCenter 4, right? So you can check that in there, 4.1, sorry. And when VAI is enabled and supported, you'll see it'll say supported. And when it doesn't know, meaning ESX could not make a decision whether or not this was supported or not supported, it'll say unknown, okay? And a lot of time that will happen is if you have a device that's attached, you don't have a plugin for it, then they'll probably say unknown. I don't know, okay? But if you have a plugin for it, and ESX went through a series of, it's a very small algorithm, okay, that decides, a decision tree, that decides whether or not VAI is supported, and it detects that, you know what, a lot of these primitives have failed, for example, then it will, instead of unknown, it'll set this as unsupported, okay? But typically when you start off, right, it's always going to start off as unknown, okay, until you start loading plugins and doing things. Let's take a closer look. So again, for, CLI type guys, in ESX 4.1, you have these commands available to you to kind of give you a view of your VAI environment. In ESX 5, this has changed, the namespace has changed. But one command that I discovered that I really, really like, and I couldn't help it myself but put it on this slide, was this one here, the storage core device VAI status get. I thought it was really cool because in ESX 4 we didn't have that. In ESX 4.1 I should say, I only had two options. I could tell VAI was on, or I could tell VAI was off. But I couldn't tell the granularity of all primitives that were supported. With ESX 5, he actually tells me, right down here, that ATS is supported, cloning is supported, zeroing is supported, delete status, meaning unmap, is supported, which is kind of cool, right? So when you have a device attached, you just by going to the command line or running whatever script that you might have, you can tell already off the bat all of the primitives that device supports, okay? In this specific example, I had a 3-part attached to this box, running our latest firmware. All right, so let's really take a closer look now. In ESX 4.1, they've added counters in ESX top. How many of you use ESX top? I've found that not many people use ESX top, and I don't know why. Maybe I can talk to some of you later, and you can explain to me why you're not using ESX top. ESX top is cool. At least I found it really, really cool, really helpful to my work. So they added counters in ESX top, right, to let us know when VAI activity is going on, okay? So those counters, you can find them up here: clone read, clone write, clone failures. You got ATS. This is the number of ATS operations that's been attempted. ATS failures, okay? Zeroing, the number of zeroing operations that have attempted, the number of zeroing operations that have failed, okay? And I can't read that last one from here. It probably says, what, megabyte zeros? Is that what it says? Yeah? Okay. So these are the columns I was just talking about, I was describing on the other side, okay? So the reason these are really cool and important now is because, as Lucas described, we've taken all the data that we used to send down to storage, we said, okay, now we're no longer doing that. We want the storage to move this data for us, right? But we need to be able to know that the activity is actually going on, right? And so these counters, when they increment, are the ones that are going to tell you that there's actually VAI operation going on and how much of it is going on, right? It's really cool. One column, when you're running your own test at home, you never want to see anything in that clone failure, ATS failure, or zeroing failure column. You want that guy to stay at 0, B0 and B0 forever. Once you start seeing that column incrementing, you have problems, okay? So that's your first cue that you have to troubleshoot something, okay? Now, this is an example of the previous screen I was just showing you. I'm zooming in here, I believe, on cloning, specifically cloning. I'm kind of illustrating the point of why ESX top in this case was really useful, okay? So if you don't have VAI, okay, that's why I have the big VA without VAI in red at the top, right? So I don't have VAI, and I've issued this command from the command line. This is a simple clone command. I'm importing a VM, and I'm going to copy it over. And by the way, do this in an eager thick format, right? Fine. Now, when I do this, when I'm cloning this VM, traditionally without VAI, what I see in ESX top is I'm going to see a lot of megabyte read and megabyte write activity. That makes sense, right? Because I'm reading the data, then I'm turn around and I write it to the same storage or to a different LUN, on that same storage box. Okay. So when you're looking at statistics, you should see lots of activities on reads and writes. Megabyte reads, megabytes writes should be high. Reads per second, write per second should be high as well, relative number, depending on what you're doing. Now, when you turn on VAI, and this is the xcopy primitive, right? Just to put this in context with everything we've talked about. Okay? If you notice now, your megabyte read and your megabyte write has gone down tremendously. That's because you're no longer sending that much I/O, actually hardly any I/O when it comes to reads and writes, okay, data to that storage box. All you're doing is you're sending the storage commands. Okay? You're sending the storage commands and you're telling the storage, this is what I need you to move. And that's why you'll see as well that your reads and writes have also tremendously gone down. Because we're no longer sending reads and writes in this case. We're sending this SCSI command that we talked about earlier, right? Extended copy, right? And that's one of the values of VAI. We've essentially taken this load from ESX and we've put it on the storage system to perform, okay? Does that make sense? We're good? All right, and then with NAS today, there's currently no way to observe NAS primitive statistics through ESX top, okay? That's probably in the future update or something. There's a long list of caveats, okay? And I noted this KB article here that you can, access to and access it on the VMware website and download it and read it, right? But a few of them that jumped out that I wanted to highlight here is because I get this question a lot as well, right? When you're doing VAI, even if you have two storage systems, okay, both are VAI-enabled, both can do VAI, you cannot do a clone operation between one storage system to another storage system and move the data using VAI. So if you did a storage vMotion, because I know a lot of people do that these days when they're migrating, like, okay, I'm going to put both systems live and I'm going to do a storage vMotion and then move my entire infrastructure from one array to the next, fine, you can do that all you want. However, your data won't be moved using VAI. The data is going to move with the regular ESX data movers, okay? So they're actually going to read and then suck it back in, all right? If you have a data store, okay, that has extents that sit on multiple arrays. So in this case, forget about different storage types of storage system. Same type of storage system. Let's say I'm talking 3-part T400. I have two of them, okay? I carve a LUN on the first one, and I carve a LUN on the second one, and then I make a VMFS out of that, okay? So a VMFS, multiple extents across multiple storage systems. I don't know how many people that do that. How many people do that? Okay, good. All right. I don't know how many people that do that. I don't know how many people that want to do that, right? But if you did do that, you wouldn't leverage VAI as well to do any type of operation on that data store, okay? Yeah. So let's talk about some of the hidden benefits and some considerations, right? How many of you guys think the VAI should always be faster? Don't be shy. It's a trick question, by the way. If I had a t-shirt, I'll give you some right now. Okay, that's fair. That's very fair. How many of you guys think the VAI shouldn't always be faster? I have one hand. Can I pick on you and tell me why you think VAI shouldn't always be faster? Can you say that again? She said every process has overhead. I like that answer, and I think I can use that and build up on my argument here. So every process has overhead. Let's think about that for a second. I've taken all the reads and all the writes that I would normally send from ESX to my array. I've taken those away, and I've told the array, you do it. And I'm talking about the cloning case in this case, right? So I was standing here, and I had this thought. If I have this straw here, like this little coffee straw, and I have this regular straw, how fast can I drink out of this compared to out of this? I can probably drink more water out of this than I can drink out of that, right? However, all the data that I'm transferring, if I'm going to move all of this water here, right, through either one of these, right, I'm no longer moving them from these. I'm having, for example, the array do that work, right? But her point was that water still needs to be processed, whether I'm sending it through these pipes or whether I'm not. Right? Whether the array is doing them on its own. Well, when you send that data to the array and you tell the array process it, now the array's got to sit there and think, okay, do I give this data priority over everything else that's still coming down the front end of the array? So you have your Oracle application talking to your 3 power blocks. You have your VMware infrastructure talking to your 3 power blocks. You have the same spindles in the back end processing all this information. You kick off VAI cloning operations in bunches on your VMware infrastructure. Do you think it's going to cause any possible overhead on your Oracle database if you're working on the same spindles? It could, right? Same cache, same spindles, right? But, somebody might make the argument, well, why would you want to do the same spindle? Yeah, that's fair. We'll separate the spindles, okay? And if my array allows me, I'll even separate cache and all of the good stuff. But at the end of the day, it's still got to be processed, right? So when the array starts making the decision of whether or not I will slow down front-end traffic in order to process all this back-end traffic that you've created for me, where is the trade-off, right? Where is that trade-off? Because we don't know how important, an array doesn't know how important your data is. I mean, these days there's a lot of cool things we're doing, quality of service and all of this fun stuff, right? To kind of give the array an indication that data right there is the important one. Cool, all of that stuff is great. But at the end of the day, the array's got to decide, do I process that back-end I.O. faster and better than I process that front-end I.O., right? And that can cause a trade-off. Which is why I'm a believer that VAI shouldn't always be faster. Because if VAI is fast enough and as fast as it can, but then introduces about 20 milliseconds more latency on my other environment, then I don't want VAI. Does that make any sense? Yeah? Okay. So that's one consideration to keep in mind. What else can we talk about? How many clone operations can your array handle? So I see a lot of documentation online, people posting results of, okay, my clone is 7 times faster. My clone is 20 times faster. Well, how many clones were you doing? And how big were those clones? I mean, I could copy, I could probably do 1,000 1 meg clones pretty fast. But then how many 100 gig clones can I do at the same time? If I'm talking VAI, right? So when you hear from your storage vendor, hey, my VAI is 7 times faster. Well, how many clones can you do at that speed? That's really a better question. Because at the end of the day, you're not going to sit there and queue up 100 clone activities that you have one at a time. We don't have that kind of time. Right? You're going to try to do as many as you can, right, to be done with that job as possible, right? So it's always good to understand the limitation of, okay, how many clones can I queue up on this storage system with VAI, okay, before I have to lose something else? And that something else could be latency, right, on other jobs, okay? That something else could be speed, right, on that specific VAI activity, right? So you got to keep that in mind too when you're implementing VAI. So when people come to you and say, yeah, my one clone took, I don't know, 90% faster. Okay, great, fine. Now talk to me about 4 clones. How much better is 4 clones? Or how much better is 4 200 gig clones, right? Because that's where you really start and talk real world, right? Because you're not moving 1 meg worth of data. You're moving terabytes worth of data. You're moving 500 gig data stores, or bigger, right? Or VMDKs, I should say. So you always got to keep that in mind as well, okay? What else? So basically, the point I was trying to make here is that VAI should not always be faster, right? One last point that I can illustrate here is, how many storage administrators do we have in the room? Okay, cool. Are you also the VMware administrator? Okay. And what about how many VMware administrators in the room? Okay. So imagine you're a storage guy. Your VMware administrator guy comes to you and says, hey, dude, I got this big clone activity I got to start off. And then you look at your array and you're like, spindle-wise, back-end-wise, you're fine. Cache-wise, your array is fine. Except you got a job going on that's really hitting your front end, right? It's just lots and lots of small IOs, right? It's not really doing much to the array in terms of back-end processing, but it's got a heavy load on the front end, okay? So you're the storage guy, you're like, man, I don't know if I can, add any more load to the storage system. The host port can't take it, right? Because I'm going to start, running into queue full situations, and then I/O starts being retried, and everybody latencies go down the drain. But then you are the VMware administrator guy that goes, well, what if I did my clone, but I did them with VAI? Storage guy is like, okay, talk to me. What does that mean? That means I can send this I/O, I can start this I/O request. I won't add that much more overhead in terms of front-end host port, right? But everything's going to happen in the back end. Can you service my I/O then? The storage guy might actually tell you, you know what, we have a deal here. Yeah, this is something I could do. And in that case, you as a VMware administrator, you might not care how fast those clones are done, as long as you can kick them off today and be done in a couple of days or whatever, right? Compared to, okay, you just want it to be done fast, right? So anyways, I know I'm going back again to this point, but don't always expect VAI to be faster. There's trade-offs, latency, and then these type of things that I just discussed, okay? Unmap and RDMs. So when you're reclaiming space, don't expect, so today ESX does not support unmapping space from removing from from an RDM, because they let the VM that you've attached to RDM controls the data that's in that RDM, right? So deleting information, for example, that virtual machine, the RDM that you present to that virtual machine, then you put a file system on it, right? That VM's operating systems control that file system. So even if you deleted anything out of that RDM, right, ESX won't do anything to that, right? But now if you deleted the actual RDM off a disk, or you deleted the VM, the actual VMDK, right? Then ESX will say, okay, fine, I can reclaim that space, right? But that's so that you wanna understand that trade-off, right? So when it comes to that, the file system, the operating system still controls the data that's inside, okay, the VMDK, the container that you attach to it, right? So when you do an unmap, don't expect that because you deleted a file inside the file system that automatically that should translate all the way down to storage into a reclaim, okay, into a reclaim activity, okay? Let's see. We talked about latencies. We talked about how many clones operation and the cache considerations. Yeah, so, that's pretty much when cache and all that good stuff comes in. So I think we're good here. So now that I've sold you on VAI shouldn't be faster, let me tell you how much faster it can be. I have a few slides here that discuss how much faster VAI has shown to be on some of the implementation. So this was a P2000 G3 MSA array. Did a few clone tests on this array. And as you can see on iSCSI and Fiber Channel, right? On iSCSI there, you had about 3.3 times faster doing a full copy. Okay, and that was just one VMDK, okay, being copied. And I can't remember the size of these VMDKs. I think they were between 10 and 20, okay, 20 gigs. And then zeroing was about 4.2 times faster. And then for Fiber Channel, you had about 1.6 and 1.3, okay? Now, you might be wondering why the numbers are different, right? Anybody wonders why? Or is that understood? Understood? Go ahead. What was the question? No, you might be wondering why is it that I get 3.2 times faster on fiber channel, on iSCSI than I do over, let's say, fiber channel while doing the same clone activity. Yes. Right. That's correct. So what the gentleman was saying is, with this fiber channel, I think it was running here at 8 gig, okay? So your transfer medium was 8 gig. So you can transfer a lot more data over 8 gig pipe than you can through that 1 gig iSCSI pipe that they use for the iSCSI test. So then when you do percentage change in terms of, percentage improvement, it looks better if the pipe was slower than it would if the pipe was faster, right? Does it make sense? Okay. So that's why the difference in the numbers here. Another thing that you'll notice with VAAI activity is that the load on the ESX server considerably goes down. Okay. Now, a lot of people make an argument for the load on the ESX server, but me, when I see where ESX is going with how many CPUs and how many vCPUs and the scalability of ESX today, I'm like, so what if it's going to use a little bit more CPU? We got servers that handle that, right? If your driving factor is to reduce a little bit of load on your ESX server, compared to sending all of this traffic to your storage array, I would say, you know what? No, do the opposite. Put the load on ESX and get a bigger box there than the storage, because everything converges to your storage. You want your storage to perform as best as you can, and you can always get a faster server or more CPUs or something like that, right? So the load should, is a good consideration, but it shouldn't be your deciding factor, right? And then if this is an example on a P4000, their implementation led numbers like 7 times faster on 40 gig VM clone, and two times faster was it? 21 times faster on zeroing, okay? And with hardware-assisted locking, ATS, they showed that with their ATS implementation, they could actually have 6 more times virtual machines per volume, right? So this is bridging the gap here between the scalability, right, performance, right, the agility, all right, that we were talking about on the first slide, right? So now that you can offload a lot of these operations to storage, right, you have a more agile environment, right? You can move things when you want, where, whichever way you want. They happen fast, okay? They happen efficiently, okay? And you're pretty much ready for that whole buzzword, right? That whole cloud computing thing, right? So you pretty much get yourself ready for the cloud. So wrapping up here, like I was saying, right? Everything that we've talked about so far enables your environment, your storage, your infrastructure for cloud, right? And as these things get even better and better to where you can start bridging, for example, VAAI clone activities between different storage arrays, right? I can leverage VAAI to move data from one array to another. It takes migration to another level, right? And then resiliency or robustness, all of those things happen based on this VAAI implementation, right? Those are things that you can leverage. My only pitch for the day, every slides, every presentation is going to have one pitch in it, right? And I saved mine for the end because I didn't want you guys to walk out in the beginning. So anyways, yeah, go by the HP booth, okay? We have a lot of experts there that are going to talk to you about cloud computing, okay? And then you can kind of see where VAAI, okay, everything we've talked about here today, how it fits into that equation, right? Because, it fits right in there, right? We're trying to enable the storage and make the storage so agile and so high performant so that when you enable it in the cloud, right, you have all the other services can happen transparently, and you don't have your storage system or your virtual infrastructure being your limiting factors for your cloud computing environment, right? So go by the booth. There's a lot of experts there that you can talk to. They have a lot of things to say to you about cloud computing if that's your interest. Other things this week, I know Matthias and Leon already did a presentation. However, there's a lot of HP sessions going on. A couple down here on cloud computing that you can still attend. And then if you want to talk to any of the HP Converged Network experts, they're also available around the HP booth. Okay, so just stop by and say hi. And I'll be hanging out there also as well if you guys have any VAI questions or implementation questions, more specific stuff under the covers. Without further ado, any questions? You guys are experts now? All right, go spread the word. Thanks. Thank you.